In this lesson, we're going to be graphing square root functions. The first one is actually not a square root function, but it's going to kind of get us started for why they write them the way they do. So I want you to look at this first equation. It says graph y squared equals x. I'm going to try and graph this on my calculator, but what I'd have to do first is get y by itself, right? So when I do that, I would square root both sides to get y by itself. And if you remember from square rooting in Algebra 1, when I square root both sides of an equation, I have to give the positive and negative value for that square root. So y actually equals a positive root x and a negative root x. When I graph that, that's actually two separate graphs. So I'm going to graph y equals root x and y equals negative root x. So let's punch that on our calculator and see what that looks like. So calculator on, I go to y equals, so you'd be at the main screen. I'm going to go to y equals, and first I'm going to graph the square root of x. So I'd go second square root, which is the x squared button, and then x, and I close that parenthesis. I'm just going to hit graph quick so you can see what that looks like. We've done one of those before. It's that slightly curved one we did the first week of school, and that one is a square root function. That's what they're going to look like today. But if I graph the second one, the negative root x, I'm going to put them both in the same graph. So I'm going to come down, I'll use the negative symbol, and then the square root of x, and close my parenthesis. Look at what that makes. There's those sideways parabolas we were talking about the first week of school. So when you see the y squared, we said those made sideways parabolas. That's what this one looks like. So if I wanted to actually graph this parabola, I would go to my table and plot some points. Ooh, look at that. Why do I have all those error messages there? And yours maybe didn't. Maybe your x was somewhere else. But look at those error messages all the way up. That's happening because my equation was the square root of x. If I have a negative under the square root, that's not a real solution. So my first answer starts with the positives. I can't have any negative answers with these because they're unreal answers. So here are my ordered pairs. Now notice, it's kind of cool the way it does this. The y1 and y2 is actually my ordered pairs for both graphs. So I can plot, if I want to plot this as one graph, I'd go plot 1, 1, and 1, negative 1. 0, 0, and 0, 0. I'd plot 2, 1.4, 2, negative 1.4. So I'm going to name some I could actually do, like 0, 0, and 1, 1, and 1, negative 1. I'll plot those first. So 0, 0, 1, 1, and 1, negative 1 as I'm making my parabola. And I'm going to keep looking down. Oh, right here at 4. I could plot 4, 2, and 4, negative 2. So I'm going to do that. 4, 2, and 4, negative 2. And I think that's enough for me to sketch my sideways parabola here. So this is what it looks like when you have a sideways parabola. This is not a function. It does not pass the vertical line test. As you can see, if I pull a line on there, look at that, I'm touching 2 points at once. So don't think that this is a function. What we're going to do the rest of today is graph functions. So ours are either going to be the positive root of x or the negative root of x. If they're the positive, they go upwards like this. If they're the negative, you'll see they go down like this. But we won't have both on one graph. Just for fun, though, we're going to do domain and range on this sideways parabola, because we will get to these later. So if I'm doing my domain, I go on my x-axis, right? Negative infinity, am I touching? No. I start touching at 0, and then I touch forever. So my my interval notation would be 0, and I am touching at 0 to positive infinity. My set notation would be values of x such that, and I start touching, remember we look at where the dot begins, at 0. So values of x such that x is greater than or equal to 0. Because when I start touching at 0, I touch to the greater than side, not the less than. Now if I decide to do my range, flip this here. My range goes bottom to top. So am I touching at negative infinity? It doesn't really seem like I am, but you have to remember that this parabola is going to keep getting wider and wider and wider. And 20 feet ahead of me, I'm going to be touching at negative infinity. So this does touch at negative infinity all the way up. And again, this arrow is going to keep going wider, wider, wider. So negative infinity to positive infinity is my interval notation. Set notation, this is new notation for us. When it's, you might have seen this called all reals. If you're touching in all spots, sometimes you'll hear that called all reals. we say values of y such that y belongs to, this is a little bit of like a capital E that's written smaller, belongs to all reals. And here's the symbol for all reals if you haven't learned it. It's kind of like a double R there with the lines. And you can practice writing that. But when we use all reals, that's the symbol we will use all the time. So again, this is saying values of y such that y belongs to all reals. And I want you to use this notation to get used to speaking math in that way. So that's my first one. Again, this is not a function. I don't want you to think this is a function. This was my example, and I kind of wanted to show you a sideways one because we talked about it before, but we hadn't actually graphed one. So again, today we will either do the positive root or the negative root, but we won't put them both on there. So the second one, you'll see now they don't have the plus or the minus sign in front of it. So my equation is y equals the square root of x plus 3. So I'm going to put this on my calculator and see how that works. So I'll clear out my two graphs I have on there, and I will do the square root of x, and then I'll close that parenthesis because I want the square root sign to end there, and then go plus 3. If you don't close the parenthesis out, that plus 3 is going to be under your square root, and that's not actually what your problem was. So when I hit graph here, hopefully what you see is that this same shape just moved up 3. So if I go to my table, I'd start at 0, right, because I have errors, again, errors before that because it's negative. So at 0, I can plot these points, 0, 3, 1, 4, and 4, 5. See those? So 0, 3, 1, 4, and 4, 5. And that's going to give me that half a parabola. That's what a square root function looks like. So our graphs today are going to look like this. Again, I'm going to do my domain and range. I'm going to try and not use my stick on here, so you guys can do this by yourself. Start on the left. As you move across, where do you first touch the line? Right here at 0. So my interval notation would be a bracket with a 0. And then I touch forever, right? So I should have switched colors. Sorry, I don't want to get your line confused. So I'm touching forever. So I'm going to say I go all the way to positive infinity. For set notation, I'd say values of x such that, and I start touching at 0, and then I touch everything greater than 0. So x is greater than or equal to 0. Y values, as I'm moving up the graph, so I'm going like this upwards, I start touching at y equals 1, 2, 3. So I would do a closed circle, or a bracket at 3, and then I touch forever as I'm going up. Don't I? Because that arrow is going to keep getting wider. So I'd say to infinity. My range for set notation would be values of y such that y is y greater than equal to 3 or less than or equal to 3? Hopefully you see it's greater than or equal to 3. So there is my graph in green there, and then my set and interval notation for those. What you want to notice is it was kind of the same graph as before, except this plus 3 moved it up 3. So now, my third graph here, this plus 3 is under the square root. So what's that going to do to it? Similar to what we did in our absolute value functions, it's going to actually move it to the left 3. So when you graph this, I'm going to have you guys graph it on your calculator and look at it and pause the video, sketch it out, and then see if you can do your domain and range also. So I want you to try the next two problems, pause it, and then I'm going to come back and just have them sketched for you. So number 3, it did start at -3 here, and then when I plotted my points, I just plotted these right here, -2, 1, and 1, 2, and I sketched my square root function. And then as I did my set and interval notation for my domain for interval, I started at -3, and I touched to positive infinity. So I had x values such that x is greater than or equal to -3. For my range, I started touching at 0. And I touched to positive infinity. So I would say values of y such that y is greater than or equal to 0. Hopefully you got those. If you didn't, this is one you could ask me about tomorrow in class and we'll do it together. And then number 4, when you look at this one, hopefully you see that you would move, because the 3 is under the square root, that would move your graph left 3, but then it's -5, so left 3 down 5 is how it moves. So this is where you start your graph. This one's positive, so it goes up as well. So here were some points you could plot, and your graph should have looked like this. And then when you did your interval notation, you would start at -3 and go to positive infinity. So values of x such that x is greater than or equal to -3. Your y value started at -5 and went to positive infinity. So values of y such that y is greater than or equal to -5. Again, I sometimes put this positive on here. That's not necessary. You don't need to put that on there. And so hopefully you did all right with those. If you didn't, you can go ahead and ask tomorrow.